And you just listen to a young girl who was saying that the Nigerian community here is totally very angry. It covers all the aspects of various techniques of our journalists.
This was the Ijaw country of the Niger Delta of the Federal Republic of Nigeria. He went to several schools to make your academic services was at Government College to Delhi. And
go gather, destroy their food. Make cultivated camp and that other camp, some more camp, you don't compensate everybody. But some of them
in its generation sometimes. Today our focus will be on the style of J.P. Clark, a poet and writer, and we shall also be very interested in his point at more dancer.
Some lives are meaningful, some are empty. Lives that are meaningful, with too much meaning and riches to offer humankind. Long after some of these earthly adventures and no more, one can still find footprints of these big lives on the pavements of our contemporary lives.
Good evening, you're welcome to the program Green Planet.
Looking at the Montreal Protocol, the second will be the ozone layer science, ozone depleting compounds, mechanisms of ozone depletion and greenhouse effect, the effects of ozone depletion, prevention of ozone depletion, and of course some conclusion. The Montreal Protocol. This was a convention between the United States and the Scandinavia to reduce the quantity of atmospheric pollution, and of course their focus was on the ozone layer, which was highly depleted by some substances they called ozone depleting substances. And it was established, of course, to control gases that damage this layer. So the Montreal Protocol trends. In 1979, that was when the US and the Scandinavia, they decided to ban all the carbon fluorochlorides. Of course, these are really strong substances that really deplete the ozone layer. And in 1985, the United Nations had a convention on the protection of the ozone layer. So, and in 1988, the Montreal Protocol came into force. In 1989, there was a revision of the Montreal Protocol and actually, putting an action to it. And then in 1992, we had other revisions, and then 25 countries actually signed the treaty. So, as Leonet, as organizations of this network, we thought it was right time for us to start contributing to the provisions of this protocol by cutting down the carbon fluorochloride production by half to 2000. That's what the protocol actually stipulated, and that stopping about 100 other ozone depletion substances by 2010, and now we are 2012, which means that all of this, the first provision would have been carried out already, and now we are preserving. If we are preserving, it means all of the first provision would have been achieved. Then ratification, over 191 countries now are parties to this protocol, and Cameroon, of course, is one of those countries. To date, production of banned ozone depleting chemicals has actually reduced by 92%. And other ozone depleting chemicals are scheduled to actually phase out by 2030, and that's why the theme of last year was phasing out of these ozone depleting substances. The ozone layer science. Of course, ozone is a natural occurring gas and protective blanket in the stratosphere, some 10 to 50 kilometers above the Earth's surface. We actually got from the divisional delegate, this area where we find ozone, and it is symbolized by O3. It is formed by the following reactions. So you have a molecule of oxygen which combines with UV, that's light, strong light from the sun, and this is happening around the ozone, so about 50 kilometers above the Earth's surface. And then when that happens, when strong lights, the UV, hit an oxygen molecule, it gets split into two oxygen atoms, and then one of these atoms will get combined to an oxygen molecule, and we all know where oxygen is coming from, right? The plants will obviously emit oxygen, and when some escape to the atmosphere, because we all can't consume all the oxygen that is produced by the plants, and we also know that oxygen is naturally occurring. It gets combined to an oxygen atom and then to form ozone. And that picture there depicts one of Leonet's activity in sensitizing the youths, Cameroonian students, about the importance of this ozone layer and how we all have to commit to preserving it. So ozone in the troposphere, just so the troposphere is the lower area in the atmosphere, and it is responsible for just slightly more than 10% of the global warming that we have. And then we realize that it is not emitted as such, but formed by reactions of other pollutants. So this ozone layer gets depleted because the release of an oxygen atom gets combined with other gases, and not the oxygen molecule. And so, because of that, that reduction, because of that oxygen, which normally would have combined with the molecule to form ozone, it gets combined with, for instance, the nitrous oxide. So there is a limitation, and that's how the ozone layer gets depleted. So it is a whole lot of chemistry and science to understand how the depletion actually happens. So right there at the stratosphere, where we actually have the ozone, it acts as a filter. So that layer, which is about 3 millimeters thick, helps to really reduce the UVB radiation reaching the Earth's surface. And it is formed under the influence of this radiation, as we've seen that when an oxygen molecule gets hit by this, ozone is the result is therefore formed. So ozone depletion is most visible during December and November at the poles, and that's when we have winter. So there's a lot of fumes in the air that really actually reduce the formation of ozone. So the gases covered under the Montreal Protocol on protecting the ozone layer include, but not limited to, the following: the chlorofluorocarbons, the hydrochlorofluorocarbons, the carbon tetrachlorides, the halogens, the gases like methyl chloroform, methyl bromide, and carbon tetrachlorides. So these gases disappear very slowly from the atmosphere. So they actually have a very long lifespan, and they move very slowly into the atmosphere, and it becomes very difficult to take them out within a short time. So taking them out requires quite a long period of time with committed human efforts, which means we have to do all the things that this morning we heard the delegate calling us to do, calling us to tell the communities to do. By preserving will require us to do a lot of things to cut down these emissions so that they all get exhausted and they become limited in their quantity or available on the stuff in the atmosphere. Yeah. So how does the ozone depletion really happens? Molecules of these ozone depleting chemicals are very lightweighted, and so they rise very slowly up the atmosphere. So once they reach the stratosphere now, they trigger a series of reactions, and these reactions, they do what? These reactions is to take out the oxygen atom that would combine normally with oxygen to form ozone, and so that is what happens. So it is not like, you know, like the ozone layer is there and then you kind of pierce it with a knife or something. It's just taking out the atom that would have combined with oxygen. And when that happens in a particular place like the Antarctica, you end up, it reduces the thickness of the ozone. So it really makes it really thin. And when it gets thin, it allows that ultraviolet to really, you know, get down to the atmosphere. And that's where we're talking about the disasters or the harmful effects. So now, usually there is a small link between ozone layer depletion and the greenhouse effect as to why we have to preserve or we will have to, you know, make a ban on these harmful chemicals. So I try to link to show some kind of relevance that ozone layer depletion is just thinning of the protective blanket by substances that, you know, deter ozone formation, whereas, you know, deterring the formation is just like taking out the atom, which I've just explained. And the greenhouse effect is about what? The emission of these greenhouse gases in the atmosphere. And when they get emitted in the atmosphere, what they do is they allow short wavelength radiations from the UV to penetrate the Earth. So the light that is supposed to be reflected back from the Earth to the atmosphere get trapped by these gases. And when they catch these radiations, they cannot allow it to escape the stratosphere. And so they stay within the atmosphere, within the Earth, and warm it up. Because they get heated up, and that causes global warming. So, because the ozone layer gets depleted by all of these substances, we are already having some effects. And what are some of these effects that we will have? Oh, I just want to recall that the delegate actually made a list, and even the song that the Green Angels sang here, they gave illustrations of some of these impacts. For instance, the skin cancers. Direct UV light on your body will cause skin cancers. The cataracts, you know, it's just like a spark of light, very intense light, will normally blind your eyes. It will suppress the immune system, which means that we will not be able to attack diseases. Our bodies will not be able to fight other diseases. Changes in plant growth rates because of intense lighting on plants. We all know that plants will grow and reproduce as a function of the amount of sunlight they receive. And when it becomes too much, it is going to change or modify their physiology. And then orientation and motility in plankton. We know plankton is, you know, the food, the green stuff we have in the oceans, and they are the building blocks of life in marine life. And when they get destroyed, we know that to an extent, we depend on marine life. For instance, the phytoplankton they have the ability to absorb carbon, to absorb a very huge amount of carbon. And so, if we want to sequester carbon and take away carbon dioxide in the atmosphere, then the ocean, through the phytoplankton, they're doing a lot of work for us already. And so the preservation of this ozone layer is paramount if we really want to find life pleasant for us on Earth. Receding and melting ice in the polar areas, the polar regions, normally will cause floods. Seas will rise because when they melt, they all find their way downstream, and they will cause rivers to rise, and they will overflow and cause floods. Of course, we'll be hearing a lot of catastrophes from floods. Evapotranspiration. Of course, when UV falls directly on the Earth's surface, what will happen? The surfaces of leaves, the soil surfaces, all surfaces that happen to, that take water will experience evaporation. And when there is intense evaporation, we will have droughts, we will have famine, we will have a water crisis, especially during the dry season, as we are having in Mile 4. We will complain that, our AES on our CAM water and AES on air cannot provide us with energy, cannot provide us with water, respectively, because we don't have the water. The water is almost all evaporated, and we are suffering. So, untimely monsoons, droughts, etc., and strong hurricanes, just like the one that happened recently in the US. It was called what? Isaac, after Katrina. So we will get all the names in the world in trying to describe all the catastrophes from hurricanes. So now, how do we prevent all of this? So I try to put some few ways by which we can prevent ozone layer. For instance, sensitizing the public. This is our responsibility. Why do we have to sensitize them? Is to be aware of those substances that can actually help in depleting the ozone layer. And when they become aware, their actions will be modified such that they take care of reducing such emissions. And you can see that is Stand Up Cameroon in one school doing sensitization during this event. We have to plant trees. Of course, I say here that when trees get planted, and we have so many of them, they will produce more oxygen, enough for us to consume, as well as ozone layer formation, because oxygen has to escape and go to the stratosphere for ozone to be formed. If we don't have more oxygen for ourselves, then we will not even have that which will go to the ozone layer. So we need to plant more trees. And then another will be to become energy efficient. And by doing that, what do? We need to unplug all electronic appliances when we are not using them. For instance, we have to buy fluorescent bulbs, because all of these electronic substances, appliances, they emit carbon chloride. And of course, that is a substance that depletes the ozone layer. We get combined with the oxygen atom very easily. And so if we do this, we are contributing to combating ozone layer depletion. Of course, changing attitudes or habits. If we are used to, boarding a vehicle every morning to work, we should learn how to work and avoid the use of car if we can really do. Because the cars too, the smoke from the exhaust, of course, will hamper ozone formation. And then we need to build low carbon factories or industries. Most of the emissions will come from our factories and industries. And if we start putting up strategies that can, reduce the amount of carbon dioxide or emissions that are emitted in the atmosphere, the better for us. And then policy development. So legislation should address environmental sustainability as well as human well-being. We are saying that we can all commit to doing this, but the first thing will be the policy, will be the legislation. Once the country cannot shape the policy such that we can use that as the basis for our actions, it becomes difficult for us to act positively or environmentally friendly. Conclusion. We've realized that the Montreal Protocol has at least gained some success in the protection of the ozone layer, because it has created awareness in many countries, especially those that are party to the protocol or to the agreement. But we still have a lot of concerns. So the questions that we ask here are as follows. What would be done to the irrevocable damage to a critical life-supporting ecosystem that must have occurred but not yet identified during early ozone depletion? What are the anticipated actions if ongoing ozone depletion will cause irrevocable or irreversible damage in the future? And lastly, what policy dimensions and strategies are necessary to counteract the assertions ongoing depletion will impact other areas of concern, such as the climate change, agriculture, biodiversity loss, and all of that. So these were the questions are really put for us to think and to use and shape our actions together. And then of course I also place some kind of reference for us to get material in our activities. I want to thank all of you for listening, and if you have questions, comments, and any points to clarify, we are available. And please, let us protect our atmosphere for the generations to come. Thank you very much.
It has an Arrey. And you just listened to a young girl who was saying that the Nigerian community here is totally very angry. Covers all the aspects of various techniques of our journalism.
This was the future country of the Niger Delta of the Federal Republic of Nigeria. He went to several schools. His major academic genesis was at the government college in Delhi.
Go gather, destroy their food. With the camp. That other camp, some more camp, no compensate everybody.
In its key generation sometimes. Today our folk can be in the style of JP Clark, a poet and writer, and we shall also be very interested in his poem Akmo Dancer.
Some lives are meaningful, some are empty. Lives that are meaningful, with too much meaning and riches to offer humankind. Long after some of these earthly adventures and more, one can still find footprints of these great lives on the pavements of our contemporary life.
Good evening, you're welcome to the program Green Planet.